Lesson 2, ionic bonds. Yesterday we talked about a chemical bond. Okay, attraction between two elements. There's a force of attraction between two elements, and that attraction only happens when you rearrange or trade or lose or gain electrons. So atoms have traded or moved their electrons. Once that happens, then there's attraction that happens. We call that a chemical bond. We're going to talk about two specific types of bonds. And this first lesson is about ionic bonds. An ionic bond is kind of its name, the definition. Two ions. Typically two oppositely charged ions. Probably your first question, what in the world is an ion, right? It's really just that first sentence of what an ion is. Further how it happens. But an ion is an atom or a group of atoms, and here's the key part, has an electrical charge to it. But atoms have a charge to it. Oppositely, I think that's the way, isn't it? Yeah. I can't go there. Yeah, still there. Sorry. It's an electrical charge. And so how do you get an electrical charge? And all atoms have a charge, but normally their charge is 0. An atom gets a charge if it loses or gains one. So what things inside of an atom have charges? What two things have a charge? Protons and electrons. You cannot move protons. Protons are always stuck inside the nucleus. Then obviously the things that can move are electrons. Electrons have what type of charge? A negative electric charge. Yeah, a negative charge. So let's think about this. If I were to gain electrons, if I were to get some from another atom, I would overall become more negative. If I were to somehow lose my electrons, then I would overall become more positive. That's what an ion is. It's an atom with a charge of some sort, either positive or negative, depending on how many electrons it lost or gained. Okay? Now, the special name for ions when there's more than one is a polyatomic ion. Yeah, it sounds really sciencey. I don't know why they have a special name for it, but it is what it is. The word poly, P-O-L-Y, do you know what that root word means? Yeah, poly, you think about that. Maybe polygon, polytheism, polygamy, many. It means the word many. It means you have a lot. So this means many ions. So it just means you have more than one atom. That's all it means. You have more than one ion. If you have more than one, you call it a polyatomic ion. Okay. So there's this kind of graph over here to the right. That's in your book, so you do not take copies of it down. But there's a list of different types of ions out there. So if you remember our conversation from yesterday, lithium, is lithium a metal or a non-metal? Lithium is a metal. What do you say metals like to do with their electrons? They like to lose them. So if you lose an electron, you will become more positive. And so lithium is a positive one because it likes to lose one electron. Same thing's true with sodium right below it. Sodium is also a metal. It's also in the same family, Na, and it likes to lose one electron, so it also is a positive one. Right? So those are examples of just plain old ions. There are some polyatomic ions in that list. I think there's like 5 or 6 of them. Guess which ones do you think are the polyatomic ions? Look at that list. What do you think? Good guess. Aluminum is actually one ion. Second to last one, carbonate. Correct. CO3. One carbon, one oxygen. That's more than one, right? Two elements. So it's polyatomic. Any other ones up there you see? Biocarbonate. Same idea. HCO3. Calcium is actually just an ion. One problem. Sulfur is one. Yeah, it's called ammonium. Ammonium is the fourth one. NH4. Two elements. And you just one element. The last one, sulfate. SO4. Sulfur and oxygen. I see one more. Actually, yeah, one more up there. The N1, which is nitrate. NO3. So the ones in green are obviously examples of polyatomic. The ones in red are just ions. Good so far? Okay, last vocabulary word we need to learn is ionic compounds. So when two ions come together and they form that ionic bond, we call that brand new substance an ionic compound. So water is an example of a molecule. Water is not an ionic compound. Salt, though, on the other hand, NaCl, the one I showed you yesterday, that is an example of an ionic compound. Never, ever, ever call salt a molecule. Salt is not a molecule. Salt is an ionic compound. There is a difference. We'll learn about next lesson why you call one thing an ionic compound and another thing a molecule. Okay? So, see how good your memories were from what I was talking earlier? How do you form an ion? What did I say? How do you make an ion? What's the key part? Lose or gain electrons. And metals, what do they like to do? They like to lose. Okay? So how do you form an ion? Whenever you lose a valence electron. And we're talking specifically, we're talking about metals like to do that. And like we said earlier, if you lose electrons, you will become more positive in your nature. It's kind of the opposite, right? So if you like to gain, you're obviously a non-metal. If you gain electrons, you'll become more negative in your nature. Or negative ion. Ionic bonds are kind of like magnets. I'll show you this example right now. This is the example I showed you yesterday, but instead of using Bohr models, I'm going to use dot diagrams. You do not have to do this. Just kind of watch. Ask you questions. So sodium Na, how many dots does sodium have? One dot. One. What about chlorine? Dot. Two. What is the goal of every element, every atom out there? A full shell, that number is 8. Needs 8. So chlorine needs one more, right? And so what happens is sodium is a metal. And like we just said above, it likes to lose. And chlorine is a non-metal, so it likes to gain. So sodium is more than half transfers electron over chlorine. Let's just kind of draw that for our chlorine. It now has its original 7 plus 1 more. So now chlorine has a total of 8. And of course, sodium. What does it have? Good. 8 plus 0, right? Yes, measure the picture. You actually go outside of it. So it also has 8 as well. So they both have 8. They are both now stable. And what we said a chemical bond is when you transfer an electron, all of a sudden there's this force of attraction that happens between those two elements. And we call that specific one an ionic bond. When they come they form something we call this whole entire thing an ionic compound, right? So this is why I say ionic bonds are kind of magnets. Do you see how there's this little positive sign here? It's positive because it lost an electron. Chlorine is negative. It's negative because it gained an electron. So much the same way the opposites attract magnets. Same thing's true with ions. If they're opposite, they'll also naturally just kind of stick together. And do things like we said, an ionic compound. Okay? One last thing I'd like to say. This is no longer called a sodium atom. We call it sodium ion. Okay? Same thing true with chlorine. It's no longer called a chlorine atom. It's called a chloride ion. Interesting, it's called chloride. Why they trade the D for the N? This is where we're going next. There's actually a specific way in which you name ionic compounds. You can't say this is sodium chlorine compound. It doesn't work that way. There's a specific way you call it and the description you name it. So we're just going to write down a couple of things and we're going to stop here. About 3 more things and we're done. So how are the formulas and names of ionic compounds written? So first of all, a chemical formula. This is another vocabulary word. This lesson is actually full of vocabulary words. A chemical formula sounds like something very technical. It's actually something very simple and something you've seen many, many times. H2O. That is a chemical formula. H2O. What elements are inside H2O? What 2 elements? Hydrogen and oxygen. So a chemical formula is a group that shows the ratio of the elements. So like you guys said, hydrogen and oxygen are making that molecule. And how many hydrogen are there? 2. How many oxygen are there? 1. That's the ratio of all the same formula. Inside of a chemical formula is a special word we call a subscript. The number 2 you see in H2O, this is called a subscript. It's a special name, just that they can make a special name for something. A subscript just simply tells you the ratio of elements in a compound. It tells the ratio of elements in a compound. So I'm going to show you a few examples of different chemical formulas and their ratios, or specifically their kind of subscripts. Okay, so like the first one in green is H2O. You guys already told me every time you have 2 hydrogen, you're going to have 1 oxygen. So the ratio is 2 to 1. Red is magnesium chloride. There is 1 magnesium and there are 2 chlorines, so it's a 1 to 2 ratio. Now the third one is a bit of a trick question. When I say trick, you can do it. What is the ratio for this substance? It's called calcium carbonate. Ooh, 1 to 1 to 3. There are actually 3 elements there. Calcium is 1, carbon is 1, and oxygen is 3. So the ratio doesn't have to be just 2 numbers. It can be many numbers there. And just so you know, like I said earlier, water, H2O, is not an ionic compound. Magnesium chloride